The Large Hadron Collider. A mysterious and marvelous project, the Large Hadron Collider, LHC, is a marvel of human ingenuity and potential danger hidden beneath Geneva. We are able to investigate the very fabric of our universe thanks to this enormous structure, which represents the pinnacle of scientific achievement. It was instrumental in the discovery of the so-called God particle, or Higgs boson, many years ago. However, a startling new development has emerged from CERN, where the well-known physicist Brian Cox has made a startling declaration. At the collider, we've noticed something strange that could have far-reaching consequences that we don't yet comprehend. Are we getting any closer to causing a catastrophe of our own? Let's investigate this scientific mystery. It is essential to comprehend the function of particle accelerators like the Large Hadron Collider in order to fully comprehend the gravity of the situation. The largest and most powerful particle accelerator in the world is the LHC, which is managed by CERN. A marvel of engineering prowess, it consists of a 17-mile ring of superconducting magnets. Its primary function is to collide protons in a manner that resembles the conditions of the universe shortly after the Big Bang by accelerating them to nearly the speed of light. A glimpse into the extreme conditions of the early universe is provided by these collisions, which produce temperatures that are millions of times hotter than those found in the core of the Sun. Since its founding in 1954, CERN has established itself as one of the world's leading research institutions. It has 23 member nations and thousands of scientists working for it. Although the Large Hadron Collider, LHC, is the center of CERN's research, it is just one component of a larger network of accelerators and experiments. Imagine a racetrack for subatomic particles rather than cars. The LHC's goal is to accelerate protons and cause them to collide, imitating the conditions and energy of the early universe. For the purpose of observing uncommon and fundamental phenomena, this process creates an environment of extreme temperature and pressure. The collider's plan is a specialized wonder, highlighting 1,232 dipole magnets that twist the molecule radiates and 392 quadrupole magnets that center these bars before crash. Other magnets also make the particles more likely to collide because they compress them. In order to protect the equipment from cosmic rays, all of this takes place 574 feet underground. In order to keep the beams in perfect condition for their journey around the ring, the inside environment is colder than space. Each of the 4 main locations around the accelerator, Atlas, CMS, ALICE, and LHCb, is equipped with a sophisticated detector for collisions. Scientists are now able to look for fundamental particles like the Higgs boson and other essential components of the universe thanks to these detectors, which capture detailed data from the collisions. The LHC is a significant scientific breakthrough, but it also raises significant ethical and existential concerns. The collider's ambitious goal to recreate a miniature version of the Big Bang was recently highlighted by prominent physicist Brian Cox, a former researcher at CERN. This goal demonstrates the LHC's ability to make groundbreaking discoveries, such as elucidating the nature of dark matter, which makes up a significant portion of the universe but is still largely unknown. The LHC's creation was a remarkable achievement that was the result of decades of research and international collaboration. The establishment of CERN aimed to expand knowledge and foster global scientific collaboration. A 17-mile ring of superconducting magnets is the design of the collider, which is underground near Geneva and accelerates protons to near-light speeds. After that, these protons are directed to collide, resulting in temperatures that are millions of times higher than the core of the Sun and emulating the conditions of the early universe. Finding the Higgs boson, also known as the God particle, is one of the LHC's primary objectives. Our understanding of mass and the fundamental structure of matter depends on this elusive particle. It was discovered in 2012, which was a significant achievement because it confirmed previous theoretical predictions and opened up new research possibilities. Beyond the Higgs boson, CERN scientists are looking into dark energy and dark matter, 2 mysterious substances that make up more than 95% of the universe. The LHC's experiments are essential for figuring out their true nature, despite their significant gravitational effects. Concerns have been raised, however, due to the LHC's enormous energies. The possibility of creating a tiny black hole is a major source of anxiety. Black holes are places in space where gravity is so strong that nothing can escape, not even light. The idea of manipulating such forces raises ethical and existential concerns, despite scientists' assurances that any black hole produced by the LHC would be minuscule and disappear almost immediately. To ensure that its operations are safe, extensive risk assessments and research on the LHC's safety have been carried out. The risks are minimal, according to scientists, and the energies involved are comparable to those found in nature. However, legal and ethical concerns have been raised regarding the LHC's potential dangers. Hawaii filed a lawsuit in 2008 to prevent the LHC from operating because of safety concerns and the possibility of catastrophic outcomes. Despite the case's dismissal, it brought attention to the widespread fear of large-scale scientific experiments. Similar legal issues in Europe reflect ongoing debates regarding how to strike a balance between scientific advancement and safety. Ethical considerations regarding our role as custodians of knowledge are also brought up by the LHC's ambitions and scale. Are we unintentionally unleashing forces beyond our control as we investigate the fundamental forces of nature? These are not merely theoretical concerns. Rather, they are pressing issues that call for thoughtful discussion and consideration. The story of the LHC is like other stories about science in general. New discoveries that change how we understand things come with moral and practical problems. The LHC exemplifies humanity's unrelenting curiosity and spirit of collaboration, demonstrating what can be accomplished when global scientists work together to answer fundamental questions. Nevertheless, it also serves as a reminder of the limitations of our comprehension and the need for humility as we investigate the universe's complexity. Our capacity to simulate complex systems has been significantly enhanced over the past few years as a result of advancements in computing and technology. These tools help CERN model the behavior of particles and accurately predict the outcomes of collisions. In addition to influencing experimental design, this capability aids in risk management and ensures the safety of the collider. The international nature of CERN emphasizes the significance of global collaboration in addressing both scientific and ethical issues by bringing diverse perspectives to bear on the difficulties posed by the LHC. With upcoming upgrades and experiments, the LHC is going to keep pushing the boundaries of particle physics. Scientists will be able to investigate higher energy regimes and the mysteries of the universe in greater depth thanks to these advancements. The Large Hadron Collider, LHC, is still at the forefront of scientific progress, whether it's probing dark matter or fundamental forces. We must, however, remain vigilant even as we celebrate the collider's accomplishments and the insights it provides. The pursuit of knowledge is a never-ending journey in which each discovery presents new challenges and opens up new horizons for investigation.